Okay, so this is part 1 of our review. It is the easy part, so I'm going to be writing with green. Ooh, okay. This first table, what you have to do to be successful on the test is memorize it. Put it in your brain, practice with a friend, ask yourselves about each one of these. So I'm going to fill them in real quick. So, orbital numbers for the s, p, d, and f. When we talked about the s orbital, we said that it can hold 2 electrons. Because it can hold 2 electrons, so I'm going to write that in there, it can hold 2 electrons. It has one little box because there's going to be 1 electron, 2 electrons. Well, you can't really see that, but 2 electrons in each box. So it has 1 orbital. For my p, I said it can hold up to 6 electrons. So it can hold up to 6 electrons, and there are 2 electrons per box, so there's 2, 4, 6, 3 boxes. So I'm going to say that it has 3 orbitals. For my d sublevel, we said that it can hold 10 electrons. So 2, 4, 6, 8, 10, and it has 5 orbitals, and it can hold 10 electrons. And for my f, I said it can hold 14 electrons. And if there's 2 in each little box, there's 2, 4, 6, 8, 10, 12, 14, and that is 7. Okay, so on your test, you might be asked to say the orbital number of whichever sublevel, and you have to be able to say, oh, my s has 1, my p has 3 orbitals, my d has 5, my f has 7, and the number of total electrons it can hold. So if you divide the total number of electrons by 2, you get the orbital number. If you multiply the orbital number by 2, you get the electrons it can hold. So memorize that. Okay, number 9. Here you go. How many protons does calcium have? So on the test, you would have to go look at the periodic table, right? But here I just gave you the element. And I see that calcium has an atomic number of 20. And I know from my acronym, for example, APE, the APE part of APE man, that my atomic number is equal to my proton number. So if my atomic number is 20, I know that I will have 20 protons. Great. Let's move on to number 10. So number 10 is asking me my atomic number, and I just said that my atomic number is the same as my number of protons, my APE acronym. So my atomic number is the same as the number of protons. So I can count the number of protons here. I know my protons have a positive sign because protons have a charge of +1, and I have 1, 2, 3. So I have 3 protons, and that means that I have 3 as my atomic number. My mass number, ooh, this one's getting a little more complex. So I know mass number is protons plus neutrons. I already counted that I have 3 protons, and I have to count the number of neutrons I have. So I have 1 right here, 2, 3, and 4 in the very back. So I have 4 neutrons. 3 plus 4 is 7. 7 is my mass number. Then number 12. What atom is this? Well, what the heck? I don't know how I'm supposed to do that. Just kidding. It's pretty easy. If I know my atomic number is 3, I can go into the periodic table and find which element has an atomic number of 3. So hydrogen is 1. Helium is 2. Lithium is 3. So I found lithium in my periodic table. How did I identify this atom? Well, I know that my proton number equals to 3, and I know that my proton number is equal to my atomic number, Whoop, whoop, whoop. And then I just found the atomic number in the periodic table. So let me do that again, a little bit faster. So my atomic number I know is the same number of protons. So I'm going to count the number of protons in this atom. I got one that's hiding right here. 1, 2, 3, 4. I have 4 protons here. I know my mass number is protons plus neutrons. I have 4 protons, and now I have to count my neutrons. And I have 1, 2, 3, 4, 5. So 4 plus 5 is 9. My mass number is 9. I always remember that my mass number is always a whole number. It is never, ever, ever a decimal. What atom is this? Well, I know I have 4 protons. 4 is my atomic number also, and so now I'm going to go to my periodic table and find which element is an atomic number 4. So that's a 1, that's my 3, that's my 4. So beryllium is atomic number 4, and I'm going to write beryllium. I can also write the element symbol, which is capital B, small letter E. How did I identify the atom? Well, same process as here. I counted my number of protons. There was 4. I know that the number of protons is equal to the atomic number, and atomic number 4 is beryllium. Okay, last few questions on the easy part. What is the center of an atom called? Well, just like the center of my cell, it is called a nucleus. This is my nucleus over here. It's a smack dab in the middle. They like to party. They're in the mosh pit. Which subatomic particles are in the center of an atom? I know that my protons, I can even see one right here, love to party. They love to be in the center of it all. And my neutrons, you can see another one right there. My neutrons are in the center. They're all in the little mosh pit. They like to party. They like to be together. They like to be the center of attention. All right, last one. How many electrons does this atom have? So I know electrons are always on the outside. They're on the outside because they're all grumpy. They're negative Nellies. They don't like to be near anyone. And they'll react with anything they touch if they feel like it. So I have 1, 2, 3, 4, 5, 6. I have 6 electrons. And this is what I use to represent an electron when I feel like not writing the word electron. Okay, so that was the easy page. Pretty simple. Now we're going to move on to my medium. Dun dun dun. The medium difficulty. And for keeping up with the color scheme, I'm going to write in orange. Ooh. Okay, so number 21. How many valence electrons do these have? So I know that valence electrons are electrons on the outermost energy level. They're on smack dab on the outside. All of them are on the outside. And I know, looking at my periodic table, I can tell how many valence electrons there are in each element just by looking at the groups. So these elements on my first group all have 1 valence electron. The elements on my second group have 2 valence electrons. And then I'm going to skip all the way over here. These elements all have 3 valence electrons. These elements all have 4. These ones all have 5. These ones all have 6. These ones all have 7. And then my last group will all have 8 except little helium. Helium is my exception here. He should go here, but he's a noble gas, so he's going to be with his noble gas buddies. So if I have to find the valence electron, how many valence electrons lithium has, I have to find lithium on the periodic table. So, there you are. And I know that lithium is within this first group. So it's going to have 1 valence electron. Now I'm going to find neon. So I know that neon is all the way over here. and it's within the 8 group. So I know that it has 8 valence electrons. Helium. So helium is also in my 8 group. It has 8 valence electrons, right? Wrong. No. Helium is my exception. Helium should be over here, but he's a noble gas, so he's chilling with the noble gases. But he has 2 valence electrons. I need to find nitrogen, and I know nitrogen is right here. And nitrogen is in this 5A group, so I know it has 5 valence electrons. Bromine. Well, bromine is right here. And I know that bromine is in group 7A, so it has 7 valence electrons. Last but not least, I have silicon. Silicon is in group 4A, so it has 4 valence electrons. So it's very easy to find how many valence electrons each element has just by looking at what group number they are on. All right, moving on. Isotopes. Fun isotopes. I know that isotopes have the same number of protons. Isotopes have the same number of protons because they are the same atom with different, you guessed it, neutrons. So isotopes are the same atoms, so the same number of protons with different number of neutrons. So some of them are skinnier, some of them are fatter. It's like Ms. Rodriguez had dimensional twins all over the place, and all of them were Ms. Rodriguez, right? They all had the same number of protons, but they all like to eat at different places. Some of them like to eat at McDonald's. The other one's Salada. The other one's Whataburger and Salada. So we're all different kinds of weights. All right, so that's just how isotopes are. Same protons, different neutrons, different weights, different masses. The 12 in carbon 12, this is isotope notation in a sentence, represents the mass number. The isotope notation in the middle of a sentence has to be the mass number. It cannot be the atomic number because atomic number is equal to protons, and protons are always the same for isotopes. All right, below I see 3 isotopes of hydrogen. So they are all hydrogen. They are all the symbol for hydrogen. They all have the same bottom number, but different top numbers. What does the top left number represent? Top left, this one, and this one. They're all different. I know that my top left number represents the mass number. What does the bottom left number represent? Well, these ones are all the same. And I know for isotopes, they all have the same number of protons. And the number of protons is the same as my atomic number. So for isotope notation symbol-wise, the bottom will be atomic number, so number of protons. The top one will be mass number, so it's protons plus neutrons. Which number stays the same? Well, this bottom left one, 1, 1, 1, so my atomic number stays the same. 27. Are these isotopes for the same element? How do you know? Well, I see that the top numbers are different. The bottom numbers are also different. I'm going to guess that they are not. No, because they have different atomic numbers. Different atomic numbers. So this notation is talking about atomic number 7. Atomic number 7 is right here, nitrogen. So this one is talking about nitrogen. And this one, atomic number 5, is talking about boron. So these are not the same element. One is nitrogen, one is boron. The atomic numbers are different. Now let's look at the bottom one. So this one has the top numbers different. The bottom number is the same. So are these isotopes for the same element? Well, yes, they are. And how do I know that? I know that it's because it has the same atomic number. So if I look at my periodic table, I see that my atomic number 7 is right here, nitrogen. So this is talking about nitrogen. And this one is also number 7, nitrogen. So they're both about nitrogen. They just have different masses. Okay? Next. True or false? Ooh, favorite stuff. And I know I made a mistake here, 32, 32, 32. Deal with it, it's fine. Okay. Protons help to identify the atom. I know that my proton number is equal to my atomic number. So my atomic number identifies the atom. So I'm going to say that this is true. If I have an element that has, or an atom that has 4 as an atomic number, that also has 4 protons. If I say, hey, go find the atom that has 37 protons, I can go, okay, 37, it has atomic number 37, also 37 protons. True or false? Protons have a mass of 1 AMU. Notice the unit. You always have to put a unit for mass. Always, 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 always. So I know that atoms have a nucleus and things in the middle of the nucleus, as we saw right here, are the big ones, the big dogs, you know. So if they are the big dogs, I know that they have to have a mass, and it is a mass of 1 AMU. So protons do have a mass of 1 AMU. Protons have a charge of -1. Nope. Protons are positive. Let me write it right here. Protons are positive. So both of those words start with the letter P. Protons are positive, so they have a +1 charge. Electrons have a charge of +1. Oh, gosh dang it, Ms. Rodriguez, stop trying to confuse me. Of course, that is also false. Electrons have a charge of -1. Electrons are my negative Nellies. They don't like to be in the mosh pit in the middle partying. They don't like that. They like to be alone. And they react if they touch something that they don't like, if they feel like it. Okay, number 32. Which atom has the greatest number of electrons? Well, if that greatest number of electrons, I'm going to think if electrons have a charge of -1, and they're asking about the atom that has the most electrons, this is probably going to be a really negative atom. Really negative. So out of all of these options, I have to find the most negative atom. So this one is K2+. Okay. So that's a +2. B is a K1+. So this is only a +1. So between 2+ and 1+, the more negative one is 1+. So I'm going to cancel out A. And then I have a neutral atom. So this means that it has a charge of 0. So between a charge of 0 and a charge of +1, the more negative one is going to be my charge of 0. So I'm going to cancel out my B. And then I have on letter D, 2 negative. So 2 negative is more negative than 0. So my answer is going to be D. My most negative atom is the one that has the most number of electrons, because electrons are negative. So it's going to be D. Now let's look at the opposite. If they're asking me to find the one with the least number of electrons, if it has the least number, I know that this is going to be more positive. So I have to find the answer that is the most positive. So let me start from the bottom up. So I know that D is 2 negative, okay? The next one is just neutral, so it's 0. I know that 0 is more positive than 2 negative, so I'm going to cancel out D. And then my B is a 1 plus. So I know that 1 plus is more positive than 0. Cancel out C. And then 2 plus. 2 plus is more positive than 1 plus. I'm going to cancel out B, and my answer is A. So in summary, the atoms that have the most number of electrons are really, really negative. So you have to find the most negative one. If they're asking for the least number of electrons, then they want you to find the more positive atom, the most positive. And that would be A for this one. Okay. So this one is going to be slightly tougher. That's why it's at the very end. So I see a hint up here. My energy level is equal to the period number. I know that my period number is my row. So my rows in the periodic table go from left to right. So I know that this is row 1, this is row 2, this is row 3, and so on and so forth. So the S block, I know that this right here is my S block. The S block includes which energy levels? Well, I know that it has period 1, 2, 3, 4, 5, 6, and 7. So my S block includes energy levels 1 through 7. Remember, energy levels is equal to the period number or the row. My P block, so my P block is right here. My P block includes periods numbers 2, 3, 4, 5, 6. So P block has energy levels 2 through 6. D block, my D is right here, my D orbital, and I know that it includes period number 3, period number 4, period number 5, and period number 6. So it includes 3, 2, 6. Lastly, my F. I know that F includes my period number 4 and period number 5. So only 4 and 5. Okay, so you have to become comfortable with looking at the periodic table and seeing how period numbers on my S block go from 1 through 7, as you would expect. On the P block, 2 to 6. On the D block, 3 to 6. And on the F, 4 to 5. All right, and that wraps up the medium challenging level. So I am going to make another video for the last parts of this review.